All right, today for our honors classes, we're going to be working on concept X, which is Hess's law. This is going to be just a continuation of what we've been doing so far with heats of reaction and heats of formation. We're going to be working with and manipulating various equations in order to figure out the overall change in enthalpy. So Hess's law is when two or more chemical reactions are combined or added. The heat of reaction of the combined reaction is simply the sum of the individual heats of reaction. This is sometimes known as the law of constant heat summation. All right, so this is just an example here where we have two equations and we know each of their heats of reactions, and we're simply going to be able to figure out the sum of them in order to get our desired equation's heat of reaction. So what happens is anything that is on both the product and exactly the same as on the reactant side are going to cancel each other out, because whatever which one got produced as a product is going to get consumed by the other reaction. So in this case, the two NOs are going to get canceled out. Now it's the only thing that's on both the left and the right. Both of these oxygens are on the same side, both on the reactant side, so we're going to leave them alone. So we simply go ahead and write the new formula, which is N2 plus 2O2. So I've combined the 2 moles of O2 are going to form 2 moles of NO2. Because of this, I can then simply add the heats of reaction together. So my new formula, which is the formation of our nitrogen dioxide, has a heat of reaction which is positive 68 kilojoules. So it's as simple as that. We're going to go through two examples. It can seem kind of confusing, but just look for key things that I'm going to be doing and saying. This is definitely one that you want to be listening to, kind of some things I'm going to be pointing out. All right, so here, these are two given reactions that are being provided. We have each of their heat of reactions here, or heat of formation, should I say, the formation of the SO3. And however, we want to find the heat of reaction for the formation of SO2. So we're going to manipulate each of these given formulas and their heat of reactions for the work on this one. I usually like to start off with looking at what my products are in my desired equation. So SO2 is what I'm looking at. So SO2 I'm going to find in my first given equation. So I want to manipulate that one to match the form of SO2 being a product. So in order to get that reactant to a product, I have to flip the entire equation, which also means I need to change the negative to a positive. Okay, so again, I've started with SO2. I want to take this first equation that has my SO2 in it and make it so that SO2 is a product, which required me to flip the entire equation and then flip also the sign of my delta H. So now I have that part set up. We're going to see here that I only need 1 mole of it. So I went from writing it exactly as is, but since I only need 1 mole of SO2, I'm going to divide everything by 2, including the delta H. So I've changed all the coefficients, divided them by 2, and I've also divided the 196 by 2 to get my positive 98 kilojoules. Now I can go ahead and set up my other equation. I'm going to write it as is because I need this sulfur and oxygen to stay on the left-hand side or the reactant side. So here I've just simply written it out. Now as you can see, I only need here 1 mole of sulfur, so I'm going to go ahead and also divide all of those by 2. So I have 1 mole of sulfur, now just 1.5, 1.5 oxygens, and my 1 SO3. And I've also divided my delta H by 2. So whatever I do to the coefficients, I have to also do to the delta H. I'm now going to take the sum of these reactions. So here I've just highlighted a couple of things that are both the same on the left and the right. So I can get rid of the SO3s. I have 1 mole of each. And then oxygens, just very carefully, I can only get rid of a half of an O2. So this now is going to get rid of it on the first equation, and this reduces it down to 1. So 1 from 1.5 to simply 1 mole of O2. I can now take the sum of this where I have 1 sulfur, 1 O2, and my 1 SO2. And there's my formula. Now I can go ahead and take the sum of my delta H's, which is 297 kilojoules. Okay, so again, we're manipulating our given formulas in order to match our desired equation to take the sum of their heat of reactions. All right, here is our other example. We're working with our two given equations again. It could be 2, 3, or 4, depending on what's provided to you. But this is our kind of goal, our target equation, and figuring out its heat of reaction. So again, I'm going to be starting with looking at my products and manipulating these formulas based on that. So I have H2S. I'm going to then take this first formula and I'm going to flip it in order to get it on the product side. So again, this was a reactant in my given equation. I want to use it as a product, so I'm flipping it, which also requires that I flip the minus to a positive sign to create an endothermic process. Now I do need, however, 2 moles of H2S. So I'm going to change that to multiplying all the coefficients by 2. So I'm simply just rewriting this. I'm just showing it to you. You can just place the 2's right in front of your equation that you already have. However, make sure once multiplying all the coefficients by 2, you also multiply the delta H by 2 as well, keeping the same positive sign as it was previously. All right, so I have that first equation manipulated. Now I need to make sure I'm forming my CO2 gas. So that's using the given equation here with our CO2. So I'm going to rewrite that down so that I have my CO2 being produced. I only need 1 mole of it, so I don't need to multiply that by anything right now. All right, so let's go ahead. We have our H2S being formed. We also have our CO2 being formed. We have the correct number of moles of those products. And what you're going to find is we can start to cross out different formulas that are both the reactant and product side. So we can get rid of our 2 SO2 gases that are both on the reactant and product side. And we also have our 3 O2s, which can get, again, crossed out. So now I can combine my formulas, and one tip is I like to set these up so that the arrows all line up. I just find it's easier to manage all the formulas. I can now combine my CS2 with my H2O, my 2H2S, and then my carbon dioxide. And now that I have this formula written out, that means I can also combine the heats of reactions to get this heat of reaction as a positive 51 kilojoules. Okay, so we'll take a little bit of practice, but you guys will get the hang of it. Again, just being very careful, paying attention to numbers. This is where writing out the information is so critical to making sure that you're getting this right. So we'll practice this in class tomorrow. However, you've seen a couple of examples. You might want to just watch it back through just so you can pick up on maybe some of the details you didn't catch while you were taking notes. And then go ahead and complete your summary or complete the Edmodo quiz.